Hello everybody, this is Engineer Rodolfo Ocati from Haro, Iloilo City, Philippines. Today we have this two-span beam. I will solve this by slope deflection method. This is the first series of lecture. Now, here is the formula of the slope deflection. Moment AB is equal to the fixed end moment AB plus the stiffness factor K times open quantity 2 times theta A plus theta B. Notice that the sequence of the subscript of letters A and B is determined from this subscript of the fixed end moment. Fixed end moment BB is fixed end moment BA plus stiffness factor times twice the theta B plus theta A. Definition of the variables are this. Now, fixed end moment, we have this formula in general: uniform load, concentrated load, triangular load, then partially filled uniform load, and couple. Okay. Then first step is the relative stiffness factor. We will whether how strong is the beam. Span AB 1 over L or 1 over 8. This is 8. Then span BC is 1 over L or 1 over 6. Get the least common divisor. So 24 it can be divided by 8. 24 can be divided or so by 6. So the least common denominator is 24. Then 24 divided by 8 is 3 times I is 3. 24 divided by 6 is 4 times I or 4I. So the stiffness factor of AB is 3, stiffness factor of BC is 4. Meaning the shorter is the span, the bigger is the stiffness factor. Then the fixed end moment, we have this formula for AB. Okay, I think I have to split the screen into two. Then okay, fixed end moment, we have the formula is PAB square over L square for AB. So substitute the first load is minus 20 times 2, this is 2. Then square of this 6 square divided by total span 8. Then the other load is 10 times this distance. 6 square of this 2, then total span 8. Simplifying this is minus 26.25. For BE, the other side on the right, formula is also the same as PEB square over L square. Now the first variable is 2, then square of this 6. I will consider the 21st. The first variable is 6, then 2 square. 20 times 6, 2 square over 8 square. Next, the 10 is plus 10. First variable is 2, then 6 square divided by 8 square. Simplifying, this is 1875. Okay. Next, the fixed end for the BC. BC, we have triangular load. The formula is WL square over 20. Notice that the fixed end moment of CB is over 30, while at BC over 20. 20 here over 20 is greater than WL square over 30. The bigger the denominator, the smaller is the value. Here, the moment in this triangular load, the base is here, so the load is usually the moment is bigger at B than at C. So at BC, denominator is 20, the bigger fixed end moment. So substitute W is 20, then times L square 6 square over 20, and this is minus 36. Fixed end CB WL square over 30 is minus 20, W is 20 again, times 6, only denominator is 30 or plus 24. You will notice that the fixed end moment EB here start negative, BE positive, then here is negative, then here is positive. Alternate negative, positive, negative, positive. That is why negative, positive, negative, positive. Okay. If we want to change to start with the positive then negative, it's okay. As for now, we start with negative, positive, negative, positive. Okay, next we have to follow stiffness factor, fixed end moment, then moment equation. The formula of the moment equation is this. We follow this basic formula. So that moment AB is this. Fixed end moment 26.25 minus times the K as stiffness factor for AB. This one 3 and 4. K here is 3, K here is 4. So that fixed end moment minus 26.25 stiffness factor times 2 theta A plus theta B. While the moment equation for BA stiffness fixed end moment is 1875 plus 3 stiffness factor times 2 theta B plus theta A. Moment BC, fixed end moment of 36 plus stiffness factor here, relative stiffness factor for 2 theta b to 2 theta c. The order of the letters is followed here, B and C. Then moment at CB, fixed end moment of 24 plus 4, 2 theta C plus theta B. Now another order of that you have to follow is the joint condition. Okay, we know that moment AB is 0 here, so equate this to 0. Okay, so simplifying, just copy this. So 6 theta A plus 3 theta B is equal to, transfer this to the right, 26.25. This is equation 1. Then another condition is that the moment BA plus moment BC must be 0. The moment on the left and moment on the right must be 0 if you add this. Okay, so we add moment BA, this one, and moment BC, this and this, we add this. So copy 1875 plus 3 2 theta B theta A minus 36 plus 4 2 theta B plus theta C, then equate to 0. Simplifying, the A here, nothing, there is A here, so this is 3 theta A. The B is 6 here, then 8 here, 6 and 8 is 16 theta B, theta C is 4. Then the sum of these two transfer to the right is negative here on the left, transfer to the right becomes positive 17.25. This is equation 2. Then last we have moment CB is 0, moment at C is 0. So CB, this is the one, copy this, 24 42 theta C plus theta B. Simplifying, the B comes first, so 4 theta B plus 8 theta C. Now when you make an equation, be sure you prioritize the alphabetical order of the subscript. Okay, A must come first, then B, then C. So here B must come first, after then C. You have 3 equations. Actually we need only 1 equation. Okay, okay, by simultaneous equation, 3 equation, we have theta A. There is a slope of the beam from A, so it follows here, then goes down, then goes up, then goes down, then goes up. So the slope at C is not 0. The slope at A is not 0, and the slope at B, it depends. Surely the theta of A is not 0, theta C is not 0. Okay, the values of the 3 thetas are this from the 3 equations. Okay, use the calculator. Then moment at A is 0. If you substitute these values of theta, we can find theta A as 0. Okay. Here, theta AB, substitute the A and B here. The values of moment AB is 0. Then the values of CB here is 0. I need only the value of moment at B or BC. Remember, we use the orientation negative, positive, negative, positive. The moment at B, usually at the support is negative, so I want this value BC, moment at BC, not moment BA. Anyway, they are equal. I usually prefer this negative BC. So the moment BC or B, that is the moment at B, I use the BC. So BC, this one, 24, uh, 36 plus 4 theta B, 36 BC, 36 plus 4 theta to theta B plus theta C. Substitute, okay. Theta B is 153, this one. Then simplifying, moment at B is 38.7857. Simplifying this, negative, then another negative 38. Then solving the reaction, cut section at B, then consider the left segment of the cut section. Moment at B is equal to 38.7857. So on the left, RA times 8, 4 and 4, minus 20 times 6, minus 10 times 2, equate to the moment B, or 38.7857. Then solving, we have one variable RA. RA is 12.6518. Then also, to find RB, take moment at C equal to 0. Moment at C is really 0. Then we have going up reaction, RB times 6 plus RA 12.6518 times 14. This is 14 from C, 14. So 4 and 6 is 10, then 2 and 2. We have 14 minus the triangular load, 1/2, 20 by 6 times 2/3 of 6. The centroid of this from C, minus 10 times 8, okay, this is 8, minus 20 times 12. This is 10 and 2, 12, equate to 0. Solving for RB, It is 63.8125. Then consider the right segment of B or BC. Solving for RC, there is a moment at B of 38.7857 here. There is a moment at B and negative. So RC times 6 in that direction. Moment due to triangular load is 1/2 20 by 6 times 1/3 of 6 or 2. Then equate that to 38. The moment here is minus 38.7857. Then RC, we have only one unknown. RC is 13.5357. Okay, we have now solved the three reactions and solved the moment. Now we can draw the shear and moment diagram. Looks like this. So the values are solved by strength of material. Now I will not discuss this anymore. Even though you need to solve this, you need to solve this. This is used in the design. The change of moment from negative to positive, there is a step up of the rebars, so that reinforcement on the top and reinforcement at the bottom and reinforcement at the top on this change and sign of the moment. Okay, now the solution to this problem is now solved. Okay, then I will give to you a challenge to solve this problem. Change the first load concentrated of 15, another load of 12. Instead of 20, make it as 15. Instead of 10, make it 12. And W 10. Then solving for the theta and the moment, we have this. Simply, I will not show the solution. You have to do it on yourself. RA is 10.83, RB is 40.718, RC is 5.446. Then another challenge problem for you. P1 is 12 here, then P2 is 10, then W is 10. Okay, there is a corresponding also change in the distance. 2, 4, 3, 6, 2, 4, change this to 3, then 6. Then the answer are stiffness factor 2 and 3. Moment at B is 26.44. The equation are also given here as guide for your answer. Equation 1, equation 2, and equation 3. Then the theta are theta A 5.5679, theta B minus 0.5432, theta C is minus 1.7284, RA is 9.728, RB 30.679, RC is 5.593. Second challenge problem for you. Then we have also the third. Okay, just follow this change of values of P and W, then distances. Then we have the corresponding stiffness factor and moment at B. Then the equation also shown here, equation 1, equation 2, equation 3. Then the corresponding solution to theta A, theta B, theta C. Then RA, RB, RC. Okay, that's end the lecture for this beam using the slope deflection. And I will be happy if you subscribe my video. Then thank you and good luck.